Hi there, welcome back. Welcome to the channel and welcome to video number 2 in the restoration of the Nordmende Super 290-9. After this recent sidetrack testing the tubes, I have now got on with it and I've got some stuff to show you. The question of whether the low audio had to do with the output, with the power supply, or with something else along the chain will be probably fairly well answered today. So I've done quite a bit, and by the end of this video you will see a test of the audio section, see if we've got something right. Hope you enjoy it. Let's see if you can spot the differences. Yes, some of the chassis has been cleaned. That capacitor has been restuffed, and so has the selenium rectifier. As far as new components are concerned, the only one you can see at the top is that capacitor. There is, however, another little bugger hiding down there, which I've replaced and which took me quite a while to find actually. It's kind of weird. I couldn't figure out where that capacitor had gone. It was hiding under there, so that's been replaced as well. Now I haven't done the final cleaning yet, but we'll get there. I've just removed a lot of the big stuff off the surface, and it's starting to look pretty good. I've replaced the 2-wire cord with a 3-wire cord so that I can ground the chassis or earth the chassis on that screw down there. And all this section has been cleaned, sort of. And there's the tube that I tested in the previous video, the one that sort of sidetracked me. That one I haven't replaced yet. That's an EABC 80, but I've got spares if that's a problem. And then I've also removed the dial glass because, yeah, I was afraid of doing some damage to it. But this thing is really dirty, but it's really gratifying to see that clean up so well. And just to answer the questions I've had in the past, how do I clean this? Well, this one was actually a little bit tougher than usual, but the usual thing is I get these natural fiber brushes, okay? Take some isopropyl alcohol, dab that there, and then just start rubbing. Now the natural fiber helps a lot. Gets rid of most of the dirt without actually damaging the surface. So at the moment, all I've done is really just softened up all the grime. This obviously won't take rust, but that's softened it up. And then I use this thing. I'll show you what that is in a minute, just to clean that off. Remember, this has got to be done quite a few repetitions of. Now, what is this? Well, this is Mac, my favorite tool, chopstick. Just slice down the middle, 1mm wire, creating a sort of spring here to retain it. Then I'll take these things, which are the makeup removers that I don't use, but my wife does. Cut that in two. Just fold it up a few times. Snap that in there and tighten the spring. And we've got ourselves a perfect cleaning accessory. Give it some alcohol, and you see that? That's done. Look at that. Now, this particular bugger was a little bit tough because some of the dirt was really ingrained, and I had to get a little bit more industrious. So what I did was I took this Scotch-Brite pad. You cut a little piece like that, like this. Take another chopstick, fit that in there, tighten, and now you've got a scrubbing tool. Don't overdo it because you will get through the, you can sort of almost sandpaper this through the protective layer on this metal, but you will get that dirt that otherwise would not come out. And there we go. That is looking a lot better, isn't it? Now, as far as wires are concerned, you have to change it a little bit. To clean wires, I use another brush, same type of brush, but a little bit longer. You see, as they get shorter, they get tougher. So this is a little bit looser, and I can just keep rubbing at the wires from all directions. That part I'd already done, and then you just go back and clean it up with this guy as well. And we're looking a lot better. So that's how it's done. That's how I do it anyway. Some parts will be tougher than others. That's to be expected. But you just have to persevere. Okay? You get the idea. Now, I don't want to do an hour of this off camera, but I assure you, it's going to take me a lot more than an hour to clean up this whole chassis, which is why I do it in stages. See, I do sections. I don't like doing this. So I do bits at a time, and I do the bits that I'm working on. Like I was working on the power supply, so I sort of did this transformer section and the filter caps holder and everything else. And then I did the power amp, so I do the transformer, the output transformer, and I go on like this, and before you know it, you're at the end and the whole thing has been cleaned up. You get the idea, right? Might as well just give this a bit of a wipe. That's still far from complete. The key here is perseverance, and you'll get it looking really good. Okay, enough of the cleaning lesson. Let me put my brushes and chopsticks away, because I want to show you what I've done so far. These two guys. Well, I was going to video this, and then I thought, I've done this before. You can go back and see how I do it. I'll refer the video above. Filter capacitor, I removed it, restuffed it. This is 2 by 50 microfarads at, they were 350 volts. I put in the 450 volt ones. This just go down to the bottom. You've got the ground connected to the chassis over here, and then the 2 wires going to the respective connective points there. This selenium rectifier is no different from the others except in the physical configuration. And also it has an advantage in that coming out of the selenium rectifier is just 4 wires, okay? There are no terminals. The wires actually come out of here and go straight to their connective points. I presume when they sold these things, they sold them with slightly longish wires, so you then just cut it to length. And that's exactly what I did. I opened this up, took off the bottom, pulled out these little plates, pulled them all out, and then I replaced this with 4 1N4007 diodes in there. I made sure that they were soldered in a way that I put it on a little board, not my board, the board I designed to put on the underneath, but just another separate little board, and then insulated it properly, made sure that all the contacts at the bottom were properly insulated and protected with heat shrink. And then those 4 wires came out of the bottom. The bottom cap went back on, and this thing got connected back to the chassis. This thing's got 3 little clips. 2 of them were soldered to the chassis, so I did the same thing. By the way, I've got to get one of those monster soldering irons that Dave Tipton's got, because soldering on here was pretty tough with my soldering iron. So we've got this restuffed, because I thought maybe the voltage was a bit low, and it was indeed a bit low. I tested all the connections from the power supply to the pertinent spots on the power amplifier and the preamp, and made sure that everything that had to do with B+ was arriving properly at this EL41 output tube, and also at the ABC80, which is the detector diodes, and the triode that acts as a preamp for this. That all seems to be fine. In the process of doing all this, obviously I changed the components that I need to. That capacitor, the one on the underside, check all these resistors. I found a slight difference from the schematic up here. There's another resistor here that doesn't seem to be in the schematic. But that's not too difficult. That was actually pretty simple. Let me show you on the schematic what it is that I've done. Right, here's our schematic. And as you can see, some painting has been going on. I always love doing this because it lets you see where progress is and what's been changed. As you can see, quite a bit is actually in red over here. Everything in red has actually been changed. Let's have a closer look. Obviously, the first place we start is the power supply. That had all been checked before. And we've got the output here, the secondary. These 4 diodes were the selenium rectifier. They've been replaced now, as I've mentioned. Then we come to the first filter section of that dual filter capacitor, again replaced. Then the B plus comes over here, goes into the output transformer, through the primary there, to the anode of that EL41 power tube. It also goes through another small section of the winding, which acts as sort of hum reduction and inductive filtering, and then through a resistor to the second capacitor, this one over here. So it comes to here. And that gets filtered further, and that becomes your screen voltage over there. Now, between the screen and the anode, there is this resistor capacitor network, and it's got a switch in here. The way this works is this is a path for high frequencies to escape. Any high frequencies that can get through this capacitor resistor network do not go through your output transformer. So what you want to do is make sure that you cut off some of the high frequencies so you prevent oscillations on this guy. And the way this works is, if you have anything other than FM selected, this switch is closed. So this resistor here is completely bypassed, and there's a path between the audio being generated here and basically supply, and it comes through, and instead of going through the transformer and being induced into the output, it goes through this capacitor and gets chucked back into a low impedance supply. So you lose these high frequencies. And because you've got no resistor here when this switch is made, in other words, when FM is not selected, then all the high frequencies, a lot of the high frequencies escape. However, if you have FM selected, this opens, okay? And if this opens, that means then that less high frequencies escape because this resistor stops them or increases the limit at which they start getting cut off, right? The shelf, and more frequencies get induced on here and therefore come out the speaker. So that's your typical sort of high frequency cutoff to prevent oscillations and to prevent noise. What else do we have here? We then have a cathode biased EL41 tube. Now the way this EL41 tube is biased is with a cathode resistor over here, 170 ohms, fully bypassed with a 100 microfarad capacitor. Now this is pretty high for these tubes. So that means that basically the whole audio frequency band is being boosted. This provides a bypass for just about every frequency, including some pretty low frequencies. Now, there's a difference here. This little bit over here with an inductor and two switches. The way this works is if you have either FM selected or pickup selected, this circuit opens up and everything comes through there. If they are not selected, this is closed. I haven't really looked too closely at that, but it's got to do again with some frequency, high frequency cutouts or bypass. So I don't know. It's just one of those tone shaping things they use, and it's not interesting enough to spend too much time on there. But it works. I've checked the connections, I've checked the components, and I've replaced that capacitor. So now we go to grid stopper here, grid leak. Both are fine. That capacitor, which wasn't too bad, got replaced. That's the capacitor, the bad capacitor. But it wasn't too bad. We've got B2 plus over here through a resistor to a small filter capacitor here, which was replaced. This was a paper cap, not an electrolytic, just to filter off any noise. Then you got your plate resistor over here, where your audio is produced over there. That goes to the plate. There's a small filter to ground over here. This is a 100 picofarad capacitor, and this one looked bad. It was leaking. Now, I've never seen one of those small capacitors leak before, but this one was leaking, so I replaced it. 100 picofarads just to clear off or clean off any residual high frequency tone or noise that's on here, because at this point you're just amplifying audio. So here we've got the triode of the EABC80. You see that? EABC80 triode. And the other section of the EABC80 is way back here, the diodes doing the detection. So back to here, we've got, we've got a feedback network from here, from the speaker output, actually from the secondary of the transformer. There's a separate winding. This is pretty neat because it means that you can't really get positive feedback. Okay, so usually this just comes off one of the taps of the transformer, but this is actually a separate winding, and it's grounded at that end and comes through here, back to here, through a resistor capacitor to the, where is it? It ends up at the bottom of this pot. And what that does is really what it's supposed to do is to help with your tone shaping. So it's feeding back certain frequencies, only certain frequencies, the ones that are, well, shaped by this RC network over here, and probably also affected by the tone control over here. But that gets through here. That's the volume control over here. The main signal from the wiper goes to here, goes into the grid. What else have we got? We've got tone shaping from there to ground. So signal comes in here, whether it be a radio audio or pickup audio, and you've got a leakage through here to ground. Depending on which way you put it, you either have high frequencies or lower frequencies being favored in terms of getting through to the audio path, which is back over here. That's the capacitor that lets the audio through. And what else we get? I did check those. I forgot to paint them, but they're fine. And what else? And that's it. And now we are at the point where we've got the whole path from the pickup input, right? TA over there, all the way in. If we switch pickup, that goes through, and we should be able to hear whatever we feed into the pickup at the speakers. Will it work? Well, let's have a look at what these components look like on the underside first, and then we'll test it. This really doesn't look like much, but there are quite a few components swapped out. You can see some of the capacitors I've replaced. There, that's the electrolytic, the cathode bypass cap. There's another one down there. There's another one in here, that one there. I've used those black capacitors, so they actually fit in a lot better on this radio. They don't stick out so much. But that really is it. You know, there's not that much that's been replaced here. When we look at the schematic, we get a better idea of what it is we've done. But everything was fairly accessible. It's not too tightly wound and interlocked. So it worked out pretty well. So really not much to be said. We've still got a lot to do, but at least the audio section is done. All that still needs to be done. But I now know that I can feed a signal into the audio input, which is into the phono socket, which is that one over there at the top. And I should be able to get the audio coming out of the speakers. Just one more detail. I've changed out the dial bulbs, the light bulbs. They were all burnt out, but that particular one had broken the clip at the back, so I had to solder it in. There's the other one over there. I've also cleaned the switches, or rather the electrical section of the switches with contact cleaner in there. I just wanted to make sure we weren't having any breaks because of those bad or dirty switch connections. Okay, I think I'm all set to test this. I've got pickup selected. I've got the signal generator producing a 1 kilohertz tone, 100 millivolts RMS. That's going straight into the pickup input at the back. The speaker is going into my dummy load over here. I can choose speaker or dummy. Let's leave it on speaker for now. I've got 8 ohms. I think it should be 4 ohms. And the scope channel 3 is monitoring that speaker output, so we'll be able to see that on the scope as well. Now I'm going to put this on at maximum volume. Still no power arriving here because my dummy load is switched off. Now I've got the Variac producing the full 230 volts. I've got one light bulb on, so only the 40 watt bulb is in line, and I'm going to switch it on. We'll have to just look at that. That is as expected. It's receiving, the radio is seeing 200 volts, 100 milliamp draw. So let's see what we get. Let the tubes warm up a bit. I've got this on maximum. Oh, here it is. Whoa, that's pretty loud. That's pretty loud. I'm going to put it on dummy load so we don't hear the noise. That is pretty loud. What is that? That's already distorting. That's the tone control. It's a bit dirty, you can see that. Let's put it about midway. Seems to be a bit of noise on there, but then the pot hasn't been cleaned. But what is it that we're actually seeing here? 1.17 volts RMS at maximum volume. Bear in mind I've got 100 millivolts. I'm going to increase that to 200 millivolts coming in. And I need to drop there's the distortion, clipping, about 2 volts. It's already distorted, 1.5, 1.6 volts. That is with 4 ohms. If I put 8 ohms on here, ooh. I'm not sure what that speaker is. I think it's closer to 8. Usually it's about 4 to 6 or so, but I've got 8 ohms on here. That's 2.5 volts, whatever that is in watts. But you know what? What I wanted to check was whether the audio level was fine. And it certainly is. And the tone control is working. Let's see what happens if I change the frequency to 5 kilohertz. Yeah, it comes down a bit. Well, not really. That's the tone control I'm operating here. Let's go down to 500 hertz. Woo. This thing is pretty bass heavy. Let's go down, down. That is 100 hertz. Tone control, more bass, yeah. This thing is pretty bass heavy, but I suppose it depends on the cabinet, and we'll only be able to really evaluate what it sounds like when we've got it in the cabinet with its actual speaker. The speaker's got a couple of inductors on the actual speaker connection, so that might also affect the tone, but the point is, this thing's working. Oh, I was testing this thing. Let me go back to 1 kilohertz. I was testing this thing with, there's quite a bit of hum on there. Mind you, this whole thing is wide open. That's full volume, amplitude 200 millivolts RMS, but I've got full restriction on here. So I'm going to give it another light bulb. That's now 100 watts in line. The radio is seeing 208 volts. Let me give it another light bulb. Now it's seeing 220, and let me give it another light bulb. So I've got a 200 watt light bulb as my current limit. And what do we get here? Okay, call that sort of undistorted. That's 4 volts RMS, 4 volts into 8 ohms. So 416, it's about 2 watts. If I give it 4 ohms, obviously goes down a bit. And clipping starts earlier. So that is 3 volts, 3 squared is 9 divided by 4. That's about 2 1/4 watts. It's what I usually see on these things with the EL84s. And as far as I know, the EL41 is very similar to the EL84. So this is nothing unusual. So I'm actually quite happy. I was pretty concerned that the low volume level, let me put that down a bit, that the low volume level was something to do with the output section. The tests that I did on the output tube, quite frankly, was just me arsing around, just experimenting, because I could very easily have just put a tone in the back. I didn't do that. I get sidetracked because I find things interesting and then I go into them. And I thought figuring out how to test this thing without a tester, just to see if I could, would be fun. And I did that video and a lot of you seem to have liked it. So I probably will be thinking about building a little really dedicated tester for these German tube radios, the ones that I normally use. And I'm still thinking about it. I haven't made the decision yet. The point is, audio section's working, power supply seems to be fine, and that's a good place to stop for now. So I want to thank you for your company. Hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching, bye for now and stay safe.